Chapter 9, Section 2, the Pythagorean Theorem. The Pythagorean theorem it only works for right triangles. So when we're talking about right triangles, we could apply the Pythagorean theorem. And it helps us find side lengths. The theorem is actually a squared plus b squared equals c squared. In this formula, a and b are going to be the legs. The legs of a right triangle, remember, are the sides that form the right angle. And then C is going to be the hypotenuse. And remember, the hypotenuse of a right triangle is the side that is opposite the right angle. A Pythagorean triple is a set of three whole numbers that make the Pythagorean theorem true. So if you had a right triangle and all of the sides were whole number, that had the length that were measured in by whole numbers, then that would be called a Pythagorean triple. This first example says, find the length of the hypotenuse of the right triangle. Tell whether the sides of the side lengths form a Pythagorean triple. Notice in this example, 7 and 24 would be my A and my B. And it does not matter which one is A and which one is B. You can put them in any order into the Pythagorean theorem. And then X would be the hypotenuse because it's the side that is opposite my right angle. Go ahead and plug these in. And when you do, you would get 7 squared plus 24 squared equals X squared. You could again have 24 squared plus 7 squared. The order doesn't matter there. Go ahead and do your exponents or square 7 and 24. 7 squared is 49, plus 24 squared is 576 equals X squared. Go ahead and do the addition on the left side of your equal sign. So you get 625 equals X squared. Remember, to get X by itself, or to get rid of X squared to just get an X, you have to take the square root of both sides. The square root of X squared is going to cancel the squared and the square root out, so you're just left with X. But then we also have to take the square root of 625. 625 is a perfect square. If you're in my class, you can use a calculator, so you could just plug it into your calculator. But the square root of 625 is a perfect square, and the square root is 25. So to tell whether the side lengths form a Pythagorean triple, the answer to that would be yes, they do form a Pythagorean triple because 7, 24, and 25 are all whole number lengths. This next example says find the side length, the length of the leg of the right triangle. Notice in this example, my hypotenuse is 6 square roots of 5. My longer leg is 12, and then X would be the shorter leg or the other leg of the triangle. Plug these numbers into the Pythagorean theorem. You get 12 squared plus X squared equals 6 square roots of 5 in parentheses squared. A really quick reminder on radical rules. The 6 square roots of 5 in parentheses squared, that means that we need to square both 6 and the square root of 5. Remember, the square root of 5 squared, or the square root of anything squared, is just going to be the number that appears inside of the square root sign. So the square root of 5 squared would just be 5, but then 6 squared is 36. So you would have to multiply 36 times 5 to get your answer, which is 180. And then 12 squared was 144. So I have 144 plus X squared equals 180. I need to subtract 144 from both sides, which gives me X squared equals 36. When I take the square root of both sides, I get X equals the square root of 36, which is a perfect square, which is 6. If this question didn't ask us to tell whether this is a Pythagorean triple or not, but this set of three numbers would not be a Pythagorean triple because 6 square roots of 5 is not a whole number. This next example asks us to find the area of the triangle to the nearest tenth of a meter. Notice that I have an isosceles triangle with side lengths of 8, 8, and 10. To find the area of a triangle, I have to do 1/2 base times height. The height is what I have a problem with because it is h right now. But remember, the height goes from the one angle or one vertex in the triangle, and it forms a right angle on the side opposite. So in this case, I have h. The only thing you have to be careful about here is, if you notice, when I have the altitude, it's splitting it into two right angles. These right angles are actually going to be congruent right angles because their hypotenuses are the same and they're sharing side h. But also remember that because this is an isosceles triangle, that h is going to split the base, which right now is 10, in half. So this side, each side of the the altitude h, or the height h, would be 5 on the bottom. So what I do is I plug in 5 squared plus x squared equals 8 squared. 5 squared is 25. 8 squared is 64. I need to subtract 25 from both sides to get x by itself. I get x squared equals 39. Take the square root of both sides, and you get x equals the square root of 39. Go ahead and leave it in radical form right now. Now what I need to do is I need to plug in the height, which we just found was the square root of 39, times the base, which is 10, and plug that into the area of a triangle formula. So I'm going to have 1/2 of 10, the base, times the square root of 39, which is the height. Go ahead and take half of 10. Half of 10 is 5. 5 times the square root of 39 is 31.22 meters squared. And again, you can plug that into your calculator and you should get 31.22. And remember, area is always in units squared, so make sure you put meters squared on your final answer. The next example says 2 antennas shown in the diagram are supported by cables 100 feet in length. If the cables are attached to the antennas 50 feet from the ground, how far apart are the antennas? They've already drawn us a diagram. First of all, think about a flat piece of land. And if you were putting up antennas into the ground, you would want the ground and the antennas to form a right angle. So what we're looking at is 2 right angles formed by the ground and the antennas that they've put attached cables to. They've gone ahead and they've even labeled this diagram for us, which is very nice. I need to find the length of one of the legs. So I would plug in 50 squared plus x squared equals 100 squared. Well, 50 squared is 2,500, and 100 squared is 10,000. So I have 2,500 plus x squared equals 10,000. Subtract 2,500 from both sides, and you get x squared equals 7,500. Take the square root of both sides, and you get x equals the square root of 7,500. If you look at the diagram again, it asks us how far apart are the antennas. The square root of 7,500 is only the length of one. It's only the distance from one antenna to where the 2 cables are meeting. To find the distance between the 2 antennas, I need to go ahead and double that length because there's 2 cables that are joining 2 different poles. So we have 2 of the congruent triangles between the poles. So I would take 2 square roots of 7,500, and to actually plug that into your calculator, you would get 173.2, and it would be feet apart. Today's assignment is on page 538. It's numbers 8 through 30 even.